the equipment. We're going to talk more about a pump system and operations, okay? Where's our pump at? Y'all see it? Yep. Okay. Which one's our suction line? A or B? A. Y'all see it? Is it bigger? All right. So, do y'all see a wash strainer on there?
Yeah.
Where? Right here? Okay, what about a check valve? Y'all see that anywhere?
Yes.
Where? Right there? Can you see the laser pointer on there?
Yeah. Not this one.
I don't think so.
So wash strainer, check valve, right?
Said below.
Where's the wash strainer at? Is it on the suction or the discharge?
Suction.
Where's the check valve at?
Discharge.
Okay, so we're gonna go over why. Okay, so there's multiple different types of wash strainers. What's the difference between a strainer and a filter? Did someone just huff at me?
No.
Am I boring y'all?
I just
Filter, cleans it out, and the strainer just.
Strainer catches solids, right? Do you strain your noodles or do you filter your noodles?
strainer.
All right, so is there going to be a filter or a strainer on the inlet of our pump?
Strainer.
Strainer. This is strainer. Okay. Filter, an example of one. They have all different types of filter elements. This one's just for like a water, like a pool, right? Or for your refrigerator. There's all kinds of different types depending on what they're filtering and what they're trying to filter out. And there's multiple different shapes and designs of strainers too. You got wash strainer, which is very common. These are dual basket strainers. One of them is in the hot unit. Y'all will learn about it next semester. The reason you have two is so that way one gets clogged, you can swap to the other one. Okay, so assume somebody was a tomboy growing up and got a Nerf gun while their ceiling fan was on and started shooting the blades. What do y'all think? What do y'all think the ceiling fan's gonna start doing? I'll give y'all a hint.
Show.
So you gonna start wobbling?
Yeah.
Wobble, baby, wobble, but no, yeah. Okay, so what if I started doing it with BBs?
Do what?
With BBs, a BB gun. Am I gonna damage the blades? Yeah. Now imagine that the fan is spinning thousands of RPMs and weighs thousands of pounds.
Probably just.
And solids are slapping it. Am I gonna damage the impellers?
No. Yeah.
It's called surface pitting. I'm about to show y'all a picture of it. So, why do y'all think we want strainers upstream of our pump? Protect our pump from what?
Solids.
From solids, yeah. So would it make sense to have it on the discharge?
No.
No. Okay, so this is a wash strainer. Now that we've damaged everyone's earplugs. Okay, I just wanted to show y'all how that works. And then let's talk about this. So if our strainer is not clogged, are we restricting flow? No, if we're not restricting flow, PSIG going in and 20 going out. And these are our readings on our pressure gauges or pressure transmitters. What's the difference between those two measurements? It's not a trick question.
Nothing.
Zero?
Yeah.
There's no difference. So your pressure differential would be,
Zero.
yeah, the difference between the inlet and the outlet. Your pressure differential is always going to be the difference between the inlet and the outlet of something, right? So I would be, think about y'all's instrumentation. What if the last letter is I?
Indicator.
Indicator. Pressure differential indicator. Okay? Good? So we're assuming this is clogged now. What's gonna happen to our flow? So it's gonna be restricted, right? We might still have a little bit of flow, but it's gonna be less. Okay, so what's gonna happen to our, if flow's going this way, what's gonna happen to our upstream pressure if we're restricting flow? It's gonna go up, yep. So, got my straw. If I'm not restricting pressure, it's flowing, I still have pressure downstream too, right? If I restrict pressure, why are my lips getting big? Higher pressure, alright? And how much is coming on the other end, Brandy?
Barely.
Is it pressured up?
No.
No. So, we're gonna be dramatic here. If it's only, it's not gonna, well, it could. Okay, so, what's our PDI?
10.
Okay, so if your PDI is high, that means what's going on with your filter. If your flow is low, that means I said filter, my bad. If your flow is low, what's going on with your strainer? If you don't have a PDI, it's clogged, right? So if you see lack of flow upstream or downstream of the filter, or strainer, right? It's clogged. So the smaller piping, a lot of people's units apparently, smaller piping, if you have smaller piping, you're not gonna have that PDI across that instrumentation, or necessarily pressure gauges on both, upstream and downstream of it. You will have a pressure gauge on the inlet of your pump and the discharge of your pump, but you won't necessarily have one right before and right after the strainer. But if anything that's big, all of my lines were 62 inch, so forth, right? So we had it on every single strainer or filter because it was all big lines. So it's depending on your pipe sizing and the way the engineers design the pump. But also, our minimum for all of the stuff in our plant, but it's really going to be the engineers that decide. It's going to be dependent on the process that's in the piping, right? The normal pressure it's actually at, the pipe diameter, all of that's going to go into them deciding and saying, hey, this is the magic number. When you hit this number, you need to dump that strainer. You need to go ahead and, because that's going to damage the pump. If it gets to this PDI, or PD, or delta P, right? Or DP. Remember we learned all the different names for it. Okay, so our magic number was 10. But like I said, it's dependent on the process, the pipe diameter, the pressure. Engineers decide that. You make rounds and check it. Good? Okay. Where was this at? On the suction or the discharge? Do y'all remember?
Discharge.
Discharge. Okay. So, what does the check valve do again?
Bring back some.
A little refresher. Prevents what?
Backflow.
All right. So, right, we got our wash strainer on our suction. Check valve on our discharge. Let's see, I should have something in here to draw it. Nope. Okay. You can pause it real quick. Okay, so my normal flow, right? Gonna be spinning that way. It's gonna go out, right? So normally, if it's an important pump, an important process, you're gonna have at least 2. That way when your seals go out, because every so often you're gonna have to change your seals about once a year if they're designed accurately. So you want to have a standby, you want it lined up, ready to go if something starts going wrong with your other one. That way you don't lose your process in the meantime of swapping to the other pump. Following me? Yeah? Okay. So if we don't, what a check valve does is prevents into our pump, okay? Now, if it backflowed into our pump, if we had no check valve, keep in mind it's going this way, and it's catching the blades or whatever you want to call them on the impeller, right? Which way is it going to spin? Is it going to spin the correct way?
The wrong way,
It's going to spin backwards. And then it's just going to go back into the suction, right? And remember, this is higher pressure than this is, right? Okay, now let's say you start having issues with your pump and go to kick it on. Having issues with your main pump, go to kick this one on. What's that thing that connects your two shafts? Coupling. Okay. Remember I told you if your coupling's working like it should, and it's not rusted together, that's your secondary defense to protect you from damaging your driver or your pump, right? Or your shaft. So what should that coupling do? Remember it has the teeth that connect? It's going to shred, right? And disconnect the two. You'll have some work to do. But it'll protect it. Now if that coupling is rusted together, which most of them will be, you're going to damage everything. You damaging your driver, you burnt the whole pump up. And if it's a steam turbine driving it, you really mess some stuff up. Very expensive. And then you're out of a pump. Okay, so we want to be able to keep our spare lined up, ready to go. That way we can swap. Well, can we do that if there's no check valve in service? No. So, to prevent that, we put a check valve, and then flow has to stop here. None of this will be, I didn't mean to erase, but this will not be happening. Right now, our check valves are reliable. Not always. They get stuck, okay? It happens. Or they get rusted. Or, yeah, they leak back because they get stuck. Or something gets stuck in them. So next semester when we're in the hot unit, I'll actually show y'all we have intentionally one of them passing when we swap pumps. Okay? So a check valve is on the what? Discharge. And this is always. Anytime you have a pump, you should have a check valve. Strainers are 99% of the time. It depends on how viscous. What's viscosity again? Fluid resistance. But depends on how viscous the material is on if you're going to have a suction strainer or not. But usually 9 times out of 10, you're going to have a suction strainer.